So our secondary lesson for 1.3, so 1.3 part 2 or 1.3b, is going to actually pick up at the end of our last notes. We skipped over a couple word problems on purpose, because now we're going to use our algebraic expression knowledge, and we're going to relay that over to algebraic story problems. So our first thing we're going to ask you to come up with, which is kind of a pain, but it is very important for algebraic solving, is creating what's called a verbal model. So you're going to use words, or at the very least abbreviated words, to come up with a plan for how you're going to set this up. And we're going to do really basic expressions and equations, because we don't want to give you real hard ones here at the beginning of Algebra 2. So it's going to seem like we're doing too much work for an easy problem, but it's all in the process. So for this question, you have $50 and you're buying some DVDs that cost $15 each. Write an expression that shows how much money you have left after buying N movies. So one thing I notice here is they gave me the cost of the DVD, so that's going to be part of our verbal model. And then we started with $50, that's going to be part of it. And we're going to be buying a mystery number of movies, but notice they define the variable to be N. So we'll come up, when we go to write the algebraic expression part, we're going to need to make sure we use the right variable. So I already started the verbal model for you. You're going to start with your original amount of money, but then you're going to spend money. So you're going to take away the number of DVDs, movies if you want to say it that way, but multiplied by the price of one movie. So depending on how many we buy, that'll be how much money we've spent, and thus the answer would be how much money we have left. So now we're going to take that verbal model and we're going to assign variables or numbers. So if we know it, we're going to write the number down, and if we don't know it, we're going to use a variable. So the original amount was $50 minus the number of movies times the price per movie. And order doesn't really matter here so much, but I do remember a clue earlier about a movie costing $15. That's the price per movie, so that's the 15 right here. The number of movies, that I did not know, and it said we're going to be buying N movies, so we're going to use N right here. There's a multiplication sign between these two, and then it equals the amount left, which we don't know. So if I could clean this up a little bit, I would write it as 50 minus, instead of N times 15, typically we write that as 15N. So you might ask yourself, like, why is this so important that we write an algebraic expression for what is essentially a really easy math problem? Well, the human's job is to streamline the worker's work. So the employee at a store doesn't sit there and do a mental math problem every time a customer comes up and buys something. So they use a cash register. A human is the person who programs the cash register. So you have to start thinking like a computer, and that's really the whole point of us learning algebra. So we can take what we see naturally as humans occurring and translate that to a computer so they can do repetitive actions on the cash register. Because I don't know about you, but I would hate to have to do a whole bunch of mental math problems every time a customer came up. So here, I don't think they gave us any more information. So oh, nope, there's a little bit at the end here. It says, now, evaluate your expression when you buy 2 movies and when you buy 3 movies. So for 2 movies, we're going to go to our expression and plug in 2. So 50 minus 15 times 2 would be 50 minus 30, so $20. So the customer would get $20 back. And then when the customer buys 3 movies, that would be 50 minus 15 times 3. So 50 minus 45, the customer is going to get $5 back. So again, I know, if you were just solving it for your own good, you wouldn't set up an algebra problem, but it's important that we are able to translate to algebra so we can program computers. You want to buy either a CD or a DVD as a gift for each of your 10 friends, and the CD costs $13 each and the DVDs cost $19 each. Write an expression for the total amount you must spend, and then evaluate when you buy, for 4 people get CDs. So this last clue, that's going to be the last part of our question. We're going to pretend like we don't know that right now. And I do know I'm buying for 10 people. And that CDs cost $13 each, and DVDs cost $19 each. Write an expression. All right, will do. So this is I'm going to make it a little trickier than what it originally is. I'm only going to let you use one variable. So I'm going to, when we get to the variable component, that's going to make it a little trickier, is because we're only going to get to use one variable. We're going to start with what's called the verbal model. So the verbal model is words or symbols, remember, that explain what's happening. So we're going to buy some CDs, we're going to buy some DVDs, so I need to know a couple of things. I need to know the price of a CD, and I'm going to have to multiply that by the number of CDs. In addition to that, I'm going to have to know the price of a DVD, and I'm going to have to multiply that by the number of DVDs. And that's going to be my total cost. Alright, so this is where it gets tricky. It does say the price of a CD right here is $13, so I know that is a 13. Number of CDs. Until I read this last clue, I do not know that answer, so I'm going to call that X. Price of a DVD, I know, is $19. And this is where it gets tricky. Normally I just let you use another variable here to represent the number of DVDs, but they gave us this extra clue. So if we were doing this problem in class, I'd probably make you guys muscle through this for a while. But if I only have 10 friends that I'm buying for, and I buy some number of them a CD, and everybody else gets a DVD, the way I would come up with that number is I would take 10 and I would subtract X. For instance, if I bought 2 friends a CD, that would leave me with 10 minus 2, or 8 friends who would get a DVD. That was a little tricky, so don't worry about that. Alright, so now it says once you have your algebraic stuff set up, why don't you go ahead and figure out what happens when you buy 4 people a CD. So that's what I'm going to plug in for X. So when X equals 4, I get 13 times 4 plus 19 times 10 minus 4. We know this is really just a 6, right? So if I were to type this on my calculator, oh gosh, I don't know. Let me hurry up and type that. $166, I think, is what I got. What's cool about that algebraic expression is it would work for anything. Alright, let me move to my next file. So 1.3 part 2 is all about story problems. And it starts here with the path. So we're going to write a verbal model. The assigning labels part I kind of skip over, so you don't have to worry about that part. We're going to then write an algebraic model, which is, using variables and numbers from the problem. And then if we can solve, we're going to solve, and sometimes it requires us to write a sentence. So, this first question says you want to know how much money you're going to spend on gasoline. So in a typical week, you drive 600 miles, you use 40 gallons of gas. Gas is $1.25 a gallon. I wish. And your truck's fuel efficiency is 21 miles per gallon on the highway and 13 miles per gallon in town. This is a classic math teacher trick where we just throw a bunch of information at you, and a lot of this is what we call extraneous information. You don't need it. So if I think about my goal is to figure how much money I'm going to spend on gas. That's what I want to know. So amount of money, or I should say amount spent on gas. So if I think about how I could figure that out, if I already know how many gallons I'm going to buy, I don't think I need to know all this efficiency business. If I didn't know that, yeah, I'd have to use the calculation. But all I really need to know is the number of gallons, and then multiply that by the cost per gallon. So, I don't know the amount of money on gas, so I'm going to call that A. Number of gallons, totally know that, that's 40. Cost per gallon is a mystical $1.25, likely not. This was written a long time ago, apparently. So it looks like we're spending $50 on gas each month. I wish. Okay. So we might once in a while ask you to write your answer out as a sentence. So you would say, I plan on spending $50 on gas each month. All right, number 2, we have the height of the top of a floor in a building. So this particular building has a lobby, and then after that they go up to the other levels. So level 1, level 2, level 3, level 4. and at the top of the lobby it's 20 feet, and then after that you can see a consistent pattern. But for that, I don't think we need to come up with the pattern quite yet. So let's talk about the height, a verbal model for height. So the lobby's the odd duck, so he's not the same height as all the other floors, so it's the lobby height plus, after that, you're going to see that there's a consistent height of each story, so the number of levels or number of stories times the height per story, because that is consistent. So I do not know the total height, but the lobby height, I can tell right here, is 20 feet, plus the number of stories. They want to know about the 15th story, huh? So that would be 15 stories, times, can you figure out the height per story? So can you figure out the common difference here? And I'm thinking it's 12. There we go. So if I type that in my calculator, oops, I didn't type it right. Let me try that again. I hit too many multiplication signs. 200. So again, if I wanted a sentence answer, I would write something like, the total height of 15 stories in this building is 200 feet. Alright, we have two airplanes. We have Boeing, which seats 100 more passengers than the McDonnell Douglas, and the two models together seat 696 passengers. Set up a model and figure this out. Alright. So we have two different airlines here, and technically we could set it up with two different variables. Let's go ahead and set it up that way for now, and then I'll show you another way. So Boeing, let's let B represent, oh, before I do that, I need a verbal model. What am I thinking? Alright, so we have the number of passengers on Boeing plus the number of passengers on the McDonnell Douglas is going to equal the total number of passengers. Really simple verbal model. You know what? I changed my mind. Let's not use two variables. Let's do this. So, number of passengers on Boeing is not an actual number. It's an algebraic component, because look here, it says it's 100 more passengers than on the McDonnell Douglas. And I actually don't know how many people are on the McDonnell Douglas. So let's say I call the McDonnell Douglas X number of passengers. Well then, 100 more than that would be 100 plus X. See what I did there? The total is 696. So looking here, this is an equation this time. On the left side, I have some like terms. I have an x plus an x, so that's a 2x. So I have 2x plus 100 when I simplify that algebraic side equals 696. And now I can solve. Again, I know some of you are going to argue with me in class and say, oh, I solved it a different way. I was much quicker than you. And I appreciate your efforts, but our purpose today is to come up with verbal and then algebraic models. Alright, dividing both sides by 2. I should be able to do that, but I can't for some reason. So 596 divided by 2 is 298. Oh, I think I knew that. So 298, but that doesn't answer anything for me. I'd sound like a psycho if I run around going, 298, that's my answer. So they want to know how many people are in each plane. So so Boeing was 100 plus X. So there's 398 passengers on the Boeing. And then for McDonnell Douglas, that was just X, right? So there's 298 passengers on the McDonnell Douglas. There we go. So I know that looks really messy and really overly complicated for the situation, but that's what they want to see. All right, number 4. This is a great question because there's one just like this on your summative. A rental car company charges an initial fee of $4 per ride and then 23 cents for each mile. Write an equation that describes the relationship between miles, which they want you to use M, and then cost, and they want you to use C. So let's start with our verbal model. So the cost, we're going to have to incorporate any sort of initial fee. And then we'd have to figure out the cost per mile and multiply that by the number of miles. Because the further you drive, the more you're going to get charged. All right, total cost. No idea, but I know I'm supposed to use C for my variable. The initial fee is $4. And then cost per mile was 23 cents, so 0.23. And the number of miles, I do not know, but they told me I had to use M for my variable. And because I have two unknowns, until they give me more information, I actually can't do anything more to that problem. So all I was supposed to do was create the equation, and we did. All right, let's go ahead and do this hardcover book question, and then I'll go ahead and stop the lesson after that one. So I have a feeling, oh, no, I lied. We're going to skip ahead to number 9. This is the one I like to do. All right, so a gift shop advertises that they will engrave any gift purchase I purchase at their store at a rate of 6 cents per letter, but they're going to give me the first 6 letters for free. A desk plate sells for $22. Write an expression for total cost of buying a desk plate and having it engraved. So I'm going to start off with a verbal model. And the verbal model, this part here we're not going to do at all yet. Leave this to the end. So the verbal model is going to be the cost equals the cost of the plate plus the cost per letter multiplied by the letters that we're charged for. Now notice I didn't just say number of letters, I said letters that we're charged for. We'll come back to that now. Total cost, no idea. But the cost per plate is 22. Cost per letter is, they say 6 cents up here. This is the tricky part. Okay, number of letters, and they don't tell me what to use here for a variable, so I'm just going to use X. But I'm not paying for all of the letters. I get 3 free letters. So like for instance, if I buy 10 letters, I'm really only going to pay for 7 of them. So the way we set that up is instead of saying just X letters, it's X minus 3. So how many letters you want engraved, but subtract the 3 free ones because you are not going to pay for those. So now we go back and it says evaluate that if someone asks for 15 letters. So we do 22 plus 0.06, and then instead of all 15 letters, they're really going to only be paying for 12 letters here. So back to my trusty calculator. I get $22.72. All right, there we go. Excellent. All right, and that is the end of our recorded lesson for 1.3 Part 2. Remember, there's another half to 1.3 where we just simply are simplifying and evaluating algebraic expressions.